Good morning friends, myself Shankar Bhanase. Today we are going to see the examples on beta function of 5 marks problem. That is today we are going to discuss. Let's start with our first example. That is show that integral of 0 to 1 x raised to n root of 1 minus x square dx is equal to 2 n factorial 2 raised to 2n upon 2n factorial square pi by 2 if n is positive integer. We have to show that the value of the integral is nothing but that much. Okay, that is RHS. Okay, let's start to solve the example. Let us consider LHS. That is integral of 0 to 1 x raised to n root of 1 minus x square dx. As we know that root of 1 minus x square means 1 minus x square raised to half, and it is at the denominator. If you shift to the numerator, it becomes raised to minus half dx. Okay, next comparing with the result, this 0 to 1 x raised to m 1 minus x raised to n raised to p dx, we know the value. It is 1 by n beta of m plus 1 upon n comma p plus 1. We get m is equal to 2n, p is equal to 2, p is equal to minus half the power of the bracket, and n is equal to 2 power of x, which is present in the bracket. Put all these values in the result. 1 by 2 beta of 2n plus 1 upon 2 gamma minus half plus 1 half beta of 2n plus 1 upon 2 minus half plus 1. By using calculator we can get the value, that is half. Okay, half use the relation between beta function gamma m into gamma n upon gamma m plus n, that is 2n plus 1 upon 2 gamma of half into gamma of 2n plus 1 upon 2 plus half. As if you consider denominator, in the denominator is same, that is 2. If you add the numerator 2n plus 2, we know the gamma half is nothing but root pi. One more result we have to use here. Again simplify more, that is gamma n plus half root pi upon gamma of n plus 1. Taking 2 common, get cancelled. Okay, we know the value of gamma of m plus half by using duplication formula. Its value is gamma 2m root of pi gamma m 2 raised to 2m minus 1. Okay, we have to use same result for n plus half, and just put the value of m as n, and this is the value of root pi upon gamma of 2 plus n. Just multiply 2n on the both side to adjust the value of RHS, to adjust the value of this, the RHS factorial term, so that we have to multiply by 2n, and after adjustment we will get this answer. Directly we can write the answer. Okay, now let's consider next thing, the second problem we are going to discuss now. Show that integral of 0 to a dx upon a raised to n x raised to n the whole bracket raised to 1 by n, its value is pi upon n into sine of pi by n. Okay, if the value of gamma 1 by n, gamma of 1 minus 1 by n, its value is pi upon sine of pi by n. Okay, let I is equal to the integral, shift to again numerator, laws of indices, 1 by n becomes minus 1 by n. For such particular examples we have to make the substitution x raised to n is equal to a raised to n of t, so that we can use the definition of beta function. X is equal to a, taking nth root, find the value. X is equal to a into t raised to 1 by n, find the dx, that is a t raised to 1 by n derivative 1 by n t raised to 1 by n minus 1 dt. In this way we will get, and check the limits. For 0 t we are getting 0, for x is equal to a we are getting t is equal to 1. Put all these values, simplify the terms, take a raised to n common from first term, and a by n is a constant. After put the value of dt as a by n t raised to 1 by n, t raised to 1 by n minus 1. Simplify all these terms, we will get as 1 by n 0 to 1 t raised to 1 by n minus 1 1 minus t raised to minus 1 by n dt. Use the definition of beta function, that is x raised to m minus 1 is nothing but the value 1 by n minus 1, and the value of n minus 1 is nothing but minus 1 by 1. After simplification we will get the values of m and n as 1 by n minus 1 by 1 minus 1 by n. Put all these values in the result, 1 by n as it is, which examples contains already in previous in this step. Before substitution 1 by n is there, consider as it is beta of value of the integral 1 by n 1 minus 1 by n. Use the function relation between beta and gamma function. Okay, we'll get this value, and given is there, its value is pi of sine of pi by n. I have kept here. That is our RHS. Hence the proof. Okay. Let's consider one more example. 0 to 1 root of 1 minus x raised to 7 by 2 dx and the second integral. We have solved such types of example in test second. Okay. Just two integral multiplication is there. Just write an I is equal to I1 into I2. Consider I1, it is of type 4. Compare P and Q and put the value. This is the value of I1. Consider similarly go for I2. For I2, we have to make upper limit half the A, that is of type 2 result. I have written here A, and power of y should be 1. For that, take 4y common. If you take 4y common, the bracket power is half. So half will be carried with the 4y raised to half. We have to take common. And after simplification and after using the result, we will get these values. Put all these values. As upper limit A is half, m is equal to power of x, that is y, half, and the bracket power is also half. Put all these values so that it becomes I2 is equal to 1 by 4 beta of 3 by 2 comma 3 by 2. Clearly again, we have found the values of I1 and I2. Just we have to take the product I1 into I2. If you want to simplify, you can simplify, or you can keep as it is. This is the value of the integral. Product of two simple integrals. That is the case. Okay. Let's consider one more example that is of similar like type 2. Similar like example number 2. Example number 2. Same way. Similar to that. 0 to 2 y square 8 minus y cube raised to half dy. The example is there. Now, by observation clearly it does not belongs to any type of our beta functions. Type 1, 2, 3, 4. It will not belongs to type 1, 2, 3, 4, 5. So that it is an example of a substitution. That is like example number 2 in this video lecture we have seen. So what we have to make? We have to eliminate this y cube. For that, we have to eliminate this y cube and we want t, single t, and one more thing, we have to take this 8 common from the bracket, so that we have to make the substitution as y cube is equal to 8t. Okay. After that, find the value of y, that is y is equal to taking cube root 8t raised to 1 by 3. Same thing we have done with our second example also. We have make the substitution x raised to n, a raised to n t. We have found x, next dx. Okay. Same thing we have to do with this example also. 8t, find y, dy, and derivative 1 by 3 derivative t raised to 1 by 3, 1 by 3 minus 1, and obviously limit will changes to 0 to 1. Put all these values, take 8 common from the bracket. Okay. Next, 8 raised to half, similar ways make the simplification, and take all constant common and use the definition of beta function. Compare the values of m and n. We will get the value m1. Compare all the values so that we will get the values. By using definition of beta function, we will get the values of m and n. Put the value. Similar one more example you will consider. 0 to 2 root x 4 minus x square dx. Again, it does not belongs to 1 to 5 type. So that it is example of a substitution. Why it is substitution? Because it does not belongs to type 1, 2, 3, 4. Okay. Why it is not belonging to that? If type 1 is of 1 limit 1 is not there, therefore it is not example of type 1. Type 2, a should be there. Here is upper limit is 2. Now it is in the place of 4. It should be 2. Then we can use the result. Then you can use the type 2 result. Not possible. For that, it is example of substitution. X square we have to eliminate. We have to make the substitution. In the place of x square we want a single t, but we have to take 4 common also. So consider x square is equal to 4t. Find x, next dx, and change the limit. Take constant term common from the whole term, and again use the definition. M minus 1 is equal to minus 1 by 4, and n minus 1 is equal to half. So that we will get the values of m and n, 3 by 4, 3 by 2. Okay. 3 by 2, beta of 3 by 4, 3 by 2. Okay. In this way, we have seen only one important example, that is of type 2. By using substitution, we have to solve the example. Okay. And how to make the substitution? power of x we have to eliminate. Suppose x raised to n I have to eliminate. At that place we have to put t, consider t, and if constant is there, that is a raised to n in this example, and the last example 8 and 4 are there. So my substitution will be x raised to n, a raised to n, t. X find kara, dx, find dx, and then the limits, and put the values, take constant common and use the definition of beta function. Then you will get the solution of such examples. Okay, hope you have understood. Thank you.